I vape, but I don't need to vape, you know? I only do what my friends do.
And this one too, and this one, and this 100. No orange number will ever appear again, then no yellow, etc, etc. That's kinda neat, I guess. Anyways, you continue filling in the 2-digit numbers as orange. It's sort of the same as the red numbers, but a bit less triangly. Then the yellow numbers even more like an arch. Then the green numbers, and the cyan numbers, and you've effectively just created a rainbow, except with the top part stretched out. I guess that's sort of interesting, but the more digits you go up, the more colors you're going to need, and that's just going to overcomplicate things really badly. There needs to be some sort of limitation set in place, or else things are going to spiral out of control. Let's scrap this and start again, this time limiting ourselves to only 2 colors, red and orange. What can we do with only 2 colors? Well, the most obvious thing to do is highlight even and odd numbers. Let's color every number to be orange if it's even, and red if it's odd. 1s are red, 2s are orange, 3s are red, 4s are orange. Let's keep extending this outwards. Oh there's an entire row of reds here, followed by an entire row of oranges. Minus the outer ones, of course, that never changes. Wait a second, this is looking kind of familiar. Sierpinski's triangle? What are you doing here? That's kind of interesting. When you highlight the even and odd numbers in Pascal's triangle, you get another famous triangle formation, that being Sierpinski's triangle, except this weird, abstracted, pixelated version of it. Or maybe this isn't an abstracted version. Maybe this is what it looks like when you zoom into Sierpinski's triangle an infinite amount? No, that's a stupid thought. Well, anyways, that's kind of neat that you get Sierpinski's triangle, but why is that the case? There's certain things that seem to be consistent here. Let's establish the rules. An odd number plus an odd number will always equal an even number, aka red plus red will always equal orange. So will an even number and an even number, aka orange plus orange equals orange. An odd number plus an even number will always equal an odd number, aka red plus orange will always equal red. With this, we can keep extending the patterns downwards without even needing the numbers at all. After all, we're doing this because we want the color patterns. We don't really care about the numbers. Now we don't need the numbers at all. Well, that's pretty interesting and all, but 2 colors is pretty simple and Sierpinski's triangle is already pretty well known, so let's try to add a 3rd color. Instead of coloring numbers based on whether they're even or odd, what happens if we color them based on if they're divisible by 3 or not? Or, well, not just are they divisible by 3 or not, but here. How about this? Multiples of 3 will get yellow. Multiples of 3 plus 1 will get red, and multiples of 3 plus 2 will get orange. So 1 gets red, 2 gets orange, and 3 gets yellow. 4 gets red, 5 gets orange, and 6 gets yellow, etc, etc. Surely something different will happen here, right? Let's build it out. Oh, look at that, it's a triangle again. 2 more triangles of the same size, but there's definitely something different going on with these 2 as it has this orange upside down V in the middle, and oh boy, that's a lot of yellows all at the same time. As seen by these mini triangles, yellow plus yellow will always equal yellow again, meaning we can extend the yellow all the way down here. Actually, let's find all of these rules again. We've doubled the number of rules now with yellow, so we have 6. We know that yellow plus yellow equals yellow, red plus red equals orange again, orange plus orange equals red, as we've seen here, then red plus orange equals yellow, red plus yellow equals red, and orange plus yellow equals orange. That's kinda cool. Anything plus yellow always equals that same anything again, which actually isn't that surprising. We're actually 3, could that not 2? We are larger than yellow as multiples of 4 plus 3. This time there are 10 rules, so it'll be a little bit harder to figure out, but not that much. Just like with 3 colors, whichever color is remainder 0 will always output the exact same thing that is input into it. In this case, red plus green is red, orange plus green is orange, yellow plus green is yellow, and green. This time there are 5 plus orange equals here. I guess that's
Me to vape, you know? I only do what my friends do.
in this case numbers at all. After all, we're doing. I guess that's sort of
Me to vape, you know? I only do what my friends do.
And this one too, sort of interesting. That's a stupid thought. After all, we're doing this yellow and green. This time there are 10 rules, so it'll be a little bit harder to figure out, but not that.
You know? I only do what my friends do.
New Snackables by Lunchables. Made with natural cheese. New Snackables by Lunchables.
Multiples of 4 plus 1, orange as multiples of 4 much into it. Really not surprising either, it's been like that in every single iteration so far. Orange plus orange seems to give us green. Yellow plus yellow seems to give us orange. Then red plus orange gives us yellow, red plus yellow gives us green, and orange plus yellow gives us red. Huh, this is another interesting pattern. Whatever is added to red always gives out the next number in that sequence. Add red and you get orange, add orange and you get yellow, add yellow and you get green, add green and you get red. Also not that surprising since red is remainder 1, so it basically acts as if you're adding 1 to something. Great, now we can start filling out things again. Interestingly, we're actually getting groups of 3 again with our remainder zeros, which are green this time, except these sizes are a bit different. The smallest size in the 3 coloring was 2 by 2, which then went up to 1, 2, 3, 4, 5, 6, 7, 8 by 8, 2 to 8. But here it actually goes from 1 to 3, still in groups of 3. Actually, hold on, there's this one green square that's isolated from the rest. That hasn't happened before. Wait a second. Just the exact same? Actually isn't. Multiples of 4 plus Pinsky's triangle is hidden within it somewhere. If you combine it with 5, I'm sure we can figure it out. We already know a couple of base rules. Remainder 0, aka cyan in this case, going down where numbers are. But interesting seeing the previous patterns to 0 or cyan in pace. But that ends with 5, which only shows up 14 times. Then 6 also shows up exactly 14 times. And so does 7. And 0 is only 9. Huh. What do these numbers mean? Who knows? Let's extend it out even further. Okay, now we're seeing the bigger color patterns emerge. Or, well, mostly just these purple ones since everything else still seems rather chaotic. Though these 4 triangles are pretty interesting. We can get even bigger, and yeah, this is fairly neat, but meh, it's more of what we were already expecting, so let's move on to 9. 9 is 3 times 3, so we're just going to see the 3 pattern in a bit more detail. And yep, there it is. This rainbowy bit is pretty cool. Hey look, it's that evil robot from the Robots movie again. Well, a little bit different this time, but still there. Let's go even further. Hey look, it's that evil robot for a 3rd and 4th time, except the 3s and 6s are inverted? Huh. And even further. Nothing really new to point out with the 9 pattern, so let's keep going. With 10 colors, we've kind of looped around the rainbow, so let's use light gray as color number 10. With 10, we're going to see the first iteration of the 5 pattern being combined with another pattern, that being the 2 pattern. And of course, there they both are, but they're sort of difficult to pick out. Hey, look at this M made of 8s, that's kinda cool. Extending this out even further, it's really about what we were expecting. Not that these higher numbers aren't interesting, but once you add so many colors, it sort of becomes a bit more difficult to pick out the patterns, so I think this is probably about where we should stop. Actually, no, we still have one unsolved question regarding the prime numbers. Mod 2 had the smallest triangles of size 1 in groups of 1. Mod 3 had the smallest triangles of size 2 in groups of 2 by 2 by 2. Mod 5 had smallest triangle size 4 by 4 by 4 in groups of 4 by 4 by 4. Mod 7 had groups of 6 by 6 by 6 in groups of 6 by 6 by 6. When it comes to prime numbers, the pattern appears to be that the size of triangles and the groups of triangles are dictated by the modulo operator -1. Let's just check mod 11 to see if this holds true for that number as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yup, that's triangle size 10. Now to see if it's in groups of 10 by 10 by 10. Extending it out more, we see this sort of coat that envelops every single non-zero triangle again. Once again, resembling the numbers of Pascal's triangle. Okay, it's kind of hard to see since that grid is so massive now, but yeah, once again it is a 10 by 10 by 10 arrangement of 10 by 10 by 10 size triangles. Well, that was a pretty fun exploration of Pascal's triangle, but is that all there is to this? I mean, let's go back to 3 colors again. With mod 3, these are the 6 rules that we have, and this is the pattern that we get. But I mean, what if we switched up these 6 rules a bit? We don't necessarily need to follow mod 3, do we? Red plus yellow currently equals red, and yellow plus yellow currently equals yellow. Let's swap those. Red plus yellow now equals yellow, and yellow plus yellow now equals red. With this, we are officially departing from using both Pascal's triangle and modulo operators. This means that our automation will no longer work for this, and while you could probably find a way to build a different automation, let's go back to manually doing it since that's kind of fun. Whatever this pattern is, it's something completely different, so screw it, let's see what it gives us. This is interesting. Since red plus yellow equals yellow, and we have a wall of reds, we're gonna have a continuous wall of yellows down the edges as well. And hey look, an entirely yellow row, which gives us a red row, then orange, and those go back and forth like stripes. That's kind of interesting. This is definitely something pretty different. What if we try even more patterns? Well, before that, let's see the math. With 3 colors, we have 6 different rules. Each of these 6 different rules can output one of 3 colors. So that's 3 colors times 3 times 3 times 3 times 3 times 3, which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. Oh boy, that's a lot. 729 possible combinations. Oh boy, that's a lot. Oh boy, that's 729 possible combinations. Oh boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible 700. That's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible combinations. 729 possible combinations. 729 possible combinations. 729 possible combinations. Which is 729 possible 729 possible 729 possible 729 possible 729 possible 729 possible 729 which is 729 possible 729 possible 729 possible 729 possible 729 possible 700. That's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 possible 729 possible 9 possible combinations. Boy, that's a lot. 9 possible combinations. Boy, that's a lot. Which is combinations. Boy, that's a lot. Which is 729 possible 729 possible 729 possible 729 possible which is 729 possible 729 possible which is 729 that's a lot. 9 possible combinations. Boy, that's a lot. Which is 729 which is
Capri Sun. Made with all. It was just what I needed.
And arranging them into squares, but you've gone kind of bored of painting, so you want to do something else, but you're not quite sure what. As you know from your Lord and Savior by heart, the best way to quell boredom is to just start drawing patterns and stuff and see what happens. How about some number patterns? That could be kind of fun, but you know, you're an artist, so you want to get something visual out of it. Maybe there's a way to create color patterns out of number patterns? That seems like an adequate. Now, with just a bit of computing power, we can do like these two cells. We and so it's necessarily that evil robot there. Now to see since what if we split equals red? This means we're gonna have oh boy times 3 times 3 times 3 times 3 times 3, which is 729 possible combinations. Oh boy, that's a lot. Maybe that's a rabbit hole to fall into another day. That's a rabbit hole to fall into another day.
Need better sleep? We can help.
So Jonas, what are we launching today?
We gave cursor agents.
If you line up a row of bricks on a flat surface and space them exactly one brick length apart, as they fall on top of each other, each brick will knock the next one over. But the last one doesn't have anything in front of it, which lets it slide forward just enough to make the brick in front of it fall flat. And as this one slips forward, it lets the next one fall, starting a backwards chain reaction until all the bricks have fallen in a perfectly straight line. If you line up a row of bricks on a flat surface and space them exactly one brick length apart,
this art style looks incredibly simple, but almost nobody can actually pull it off. And the reason why will make you never look at a painting the same way again. While most people think art is all about messy freedom and fast brushstrokes, this artist does the exact opposite. Every single move is agonizingly slow and perfectly planned out, long before it even touches the surface. It requires total physical control and breathing management just to get it right. Because unlike regular painting, even a time is in a massive the time takes a most people have the patience to master. This art style looks incredible to get it right.
Need better sleep? We can help. Need better sleep? We can help.